I'm Jacob J. Menson, and this is my Creative Assignment 1, Finding Acceleration Along a Circular Path. In this experiment, I will be using GPS to track a car driving in a circle. By predicting the behavior of a body in circular motion and processing the position data into velocity acceleration, I can use polar coordinates to observe centripetal acceleration and compare to the expected results. The chosen path was a local roundabout. I drove at a target 10 miles per hour, and I attempted to drive in as clean of a circle as possible. That means keeping the radius constant and keeping the speed constant. So, what can we expect? We expect radial acceleration to equal v squared over r. This is known as centripetal acceleration. Angular acceleration should be 0, since the car isn't speeding up or slowing down. After conducting the experiment and gathering data, I was able to break down latitude and longitude into x and y coordinates as seen on the graph on the bottom left. This was also put into a circular graph that shows the path that the car traveled. Velocity vectors were found by differentiating these x and y coordinates. By differentiating the velocity vector, I was able to observe acceleration. As seen on the graphic on the right, this acceleration was not perfect. The car was speeding up and slowing down, and it was not following the perfect path that I had planned. Nonetheless, I was able to project acceleration onto the unit vectors in the r and theta direction. The average radial acceleration was found to be negative 2.72, which is pretty close to the expected radial acceleration of negative 2.45. The average angular acceleration was negative 0.24. This was expected to be 0, and the fact that it's not shows that the car had sped up or slowed down in average over the course of the circle. Now, what are the data implications? First, the expected results were close to the experimental results. This shows that the expected results hold real-world application. Even in an instance where the acceleration vector is all over the place, we were still able to observe a pattern that showed what we expected. Next, things like driving are bound to be unstable and yield different results than what's expected theoretically. If this system would have been under more control, it would have been a lot closer to the theoretical values, although it wasn't. Driving, flying, and any other activity that involves going in a circle when not controlled by a rail or a line will yield some sort of uncertainty that is going to be hard to approximate with just 0 and v squared over r. And that concludes my findings for this experiment. I hope it was insightful. Thank you for watching.